Right, time to get into the book now. So, part one of the book, Scope, Object and Fundamental Principles. The very basic foundations that any installation or design are built on. We need to know what's involved, what's required, what the customer expects, and how we can make that fit in with what we're going to design. So 110.1.1, the very first regulation in the book, chapter 11, explains all of the areas that the book covers, all the areas that the regulations refer to. Things like residential premises, commercial premises, down to caravan camping parks, marinas. There's a new one added in for the 18th edition, onshore units of electrical shore connections of inland navigation vessels. If you get a question in the exam saying what's included in the regulations, what's covered by the regulations, here's the list, 110.1.1. The regulations also only cover circuits supplied at nominal voltages up to 1000 volts AC or 1500 volts DC. We're looking at frequencies in the range of 50, 60 and 400 Hertz. Now, circuits other than internal wiring of equipment operating at voltages exceeding 1000 volts but being derived from an installation having a voltage not exceeding 1000 volts are covered by this book. Wiring systems and cables not specifically covered by the standard for appliances and such may also be referred to in the book. All consumer installations external to buildings, fixed wiring for information communication technology equipment, and of course the book refers heavily to any additions, alterations or installations that may affect an existing installation. Now, certain areas such as electric signs or explosive atmospheres, whilst being covered by the book, are also supplemented by an individual British standard. So, as well as consulting the book, you would need to refer to that standard whilst designing a system for a particular location, such as a fire detection, a fire alarm system. We would consult BS 5839 and construct accordingly. There are exclusions from the scope of the book as well. Things like distribution of electricity to the public, equipment on board ships, equipment on board aircraft. The list, 110.2. If you get an exam question saying what is it excluded or is the following excluded, here it is, 110.2. Now chapter 11, 111, 112 are not used any longer. 113 covers equipment, and the regulations apply to items of electrical equipment so far as selection and use goes. The regulations don't deal with the requirements of construction of assembled electrical equipment. And although I've mentioned it before, 114.1 clearly states that the regulations are non-statutory. However, they may be used in a court of law in evidence to claim compliance with statutory requirements. 115.1 installations in premises subject to licensing. Now, we have all these rules and regulations in this book which cover all installations up to 1000 volts. However, if that installation takes place in licensed premises, then if a license has to be issued for the premises, the licensing authority has an overall statutory control over that. They can add to it, they can increase the specification, and if we don't comply to that, they simply just won't issue the license. So, such as a theatre, a swimming baths, a leisure centre, we need to refer to the local authority building control section as well for any of their own special requirements. Chapter 12 then starts getting into the objects and effects. So this is the rules for the design and erection of electrical installations to provide for safety and the proper function and intended use. In chapter 13 we start covering the fundamental principles. It doesn't include detailed technical requirements, but what it does include is the information that the customer may need in their installation. So 120.3, the standard then sets out technical requirements for the electrical installation, and it refers to the following chapters, of course: Part 3 for assessment of general characteristics, Part 4 protection for safety, Part 5 selection and erection of equipment, Part 6 inspection and testing, and then of course any special locations are covered in Part 7. Chapter 13, Fundamental Principles, covers the requirements for the safety of persons, livestock and property against dangers and damage which may arise in the reasonable use of electrical installation. So it covers things like shock currents, mechanical movement, power supply interruptions, arcing and burning, and it'll be covered in more depth throughout the book, but the fundamental principles here in chapter 13, 131.1. Now 131 also refers to two terms which we need to be very conversant with, and hopefully already are, but we've got basic protection, which was formerly known as direct contact, and we've got fault protection, formerly known as indirect contact. We will be looking at those two terms in depth as we go through the book. They're the two basic protection for safety requirements throughout the entire design. So basic protection then. Persons and livestock shall be protected against danger that may arise from contact with live parts of the installation. So this can be preventing current from passing through the human body or a person or any livestock, or limiting the amount of current that can pass through the body down to a non-hazardous value. Fault protection, however, that persons and livestock should be protected against the dangers that may arise from contact with exposed conductive parts during fault situations. Now obviously a fault has occurred, so we need to prevent a current from passing through a body, or we need to limit the amount of current that can pass through in fault conditions. If we can't limit the amount of current, then we need to limit the amount of time that the dangerous current can pass through the body and reduce it down to a non-hazardous time period. So persons, livestock, fixed equipment, fixed materials adjacent to electrical equipment also need to be protected against any harmful effects of heat. Electricity can cause burning, it can cause high temperatures, combustion, ignition, even just degradation of materials. There is the risk of burns. So all electrical equipment shall be designed and installed so that it doesn't present a fire hazard to any adjacent materials. And we've just mentioned previously about limiting the amount of current. So we look at protection against overcurrent in 131.4, where persons and livestock should be protected against any injury, and property shall be protected against damage due to excessive temperatures or electromechanical stresses caused by any overcurrents likely to arise. Conductors other than live currents and any parts intended to carry a fault current need to be capable of carrying that current. Electrical equipment, including live conductors, need to be provided with mechanical protection against any electromechanical stresses or any fault currents necessary to prevent injury or damage to persons or livestock or property. We also need to protect against voltage disturbances, and we need to put measures in place against electromagnetic disturbance. So 131.6 covers things like persons and livestock shall be protected against injury, and property should be protected against harmful effects as a consequence between live parts. 6.2 atmospheric events. 6.3 subsequent voltage recovery. And 6.4 installation should have an adequate level of immunity against electromagnetic disturbance. We will be looking at that in quite a bit more depth yet. So where danger or damage is expected to arise due to an interruption of supply, suitable provision also needs to be made in the installation and installed equipment. This may be to protect against automatic restarting after failure of supply. Again, this will be covered in a lot more depth later. Once we get into the design side of things, we're looking at electrical installation needs to be designed by one or more skilled persons to provide for the protection of persons, livestock and property in accordance with section 131, which we've just covered. And we need to ensure the proper functioning of the electrical installation for its intended use. 132 then goes on to cover things that we need to take into account while designing our system, such as characteristics of available supply, nature of demand, electrical supply systems for safety services. We need to take into account environmental conditions and external influences. So in the course of that, we would look at the size of cross-section area of our conductors and the type of wiring, protective equipment used, any emergency controls and disconnecting devices needed. We need to look at prevention of mutual detrimental influences. And we also need to start considering, when we're building this system, access for future use, for future maintenance, for people to get in to actually service, maintain the equipment. And whilst thinking about them as well, we need to think about producing the correct documentation. Isolation and switching and protective devices also all need to be built into the design so that the design is fit for purpose. And of course, if we come to an alteration of an existing system, the first thing we must do before making any alterations or upgrades is consider the existing system. Is the supply capable of supporting the new additions we're putting onto it? Is the earthing and bonding arrangement in place? Are they up to current spec? If we upgrade a system, if we increase, say, add a few sockets in a house, we need to assess not only where we're going to be putting those sockets and what have you, we need to assess the system that those sockets are going to be connected to. Is it capable of supporting additional sockets? Is the earthing and bonding in place? Is the protection up to current regulations? And when we do have an addition to a system, we must install up to and upgrade existing to the current regulations. So when we're looking at the equipment, we need to select the correct type of equipment, because every piece of equipment needs to comply with appropriate British or a harmonised standard. Now, in the absence of such a standard, we are allowed to refer to an appropriate international IEC standard, or that's a standard of another country. But where equipment is not in accordance with a British or a harmonised standard, the designer or person responsible needs to confirm that the equipment provides at least the same degree of safety as that afforded by compliance with regulations, and any departures need to be recorded on the appropriate certification. So characteristics, voltage, current, frequency and power all need to be taken into account when we're selecting the right electrical equipment for our installation. And the regulations 133.2, 2.1, 2.2, 2.3 explain the requirements that we are needed to look at. We need to think about the condition of the installation as well. We need to select equipment so that it can withstand any safe stresses or environmental conditions where it's going to be used, external influences. We need to prevent any harmful effects of the equipment being installed. And also, with the event of lots and lots of new materials and inventions, we need to look very carefully at any departures from regulations and any degree of safety. Remember, it must be not less than it would be if the standard was complied with. And any such variations need to be recorded on the correct paperwork. So 134.1.1 states that good workmanship by skilled or instructed persons and proper materials shall be used in the erection of the electrical installation. Now we're going to look at those definitions of skilled and instructed persons in a little while, but it quite clearly states there that proper materials should be installed by properly trained individuals. An appropriate inspection must take place, initial verification, testing, making sure the equipment is fit for purpose, and indeed the designer needs to set out right from the off, when putting the designs down on paper, just how long the system can reasonably function before it needs its first inspection. All of the testing needs to be carried out before the equipment is handed over to the customer and put into service. And it's recommended that every electrical installation is subject to a periodic inspection. It may be running perfectly well, but there may be background underlying faults, such as insulation of cables beginning to deteriorate. By carrying out a periodic inspection and test, we can ascertain if the system is still fit for purpose. We can see if there is any underlying degradation of the system and any potential maintenance that may need to take place. And we have in Appendix 6 model forms for writing down the answers and recording the results. And all results and all information with regards to any testing and inspection of any electrical system should be maintained for the lifetime of that system. So that's part one pretty much covered, the scope, object and fundamental principles. If it's in the book, there's a list of what's included. There's a list of what's included but is supplemented by a British standard, and there's a list of what's excluded. If you get a question on anything like that, you're looking for scope, object and fundamental principles right here in part one. That's the end of this slideshow. I'll be back with the next one where we're going to look at part two, which is the definitions section. I'll see you then.